Today we're going to be doing Lab D6, Combinations of Resistances. We will be finding the relationship of the equivalent resistance to the length and cross-sectional area of the resistors in series and parallel circuits. For this lab we will need a breadboard, a multimeter, various resistors with different values, a battery pack, and 2 alligator clip wires. We will need 4 different resistors. Make sure that the largest resistor is 3 times the size of your smallest resistor, and the resistance can't be above 15,000 ohms and below 150 ohms. Here I have a 2,000 ohm resistor, a 3,000 ohm resistor, a 4,000 ohm resistor, and a 6,000 ohm resistor. These are the given values, but you still have to actually measure their resistances, as the resistance is not as exactly what it says it is. As you can see as I measure resistor 1 here. 1,989 ohms instead of 2,000. Resistor 2 is different as well, and so on with the other 2. Label each resistor R1 through R4 in order of increasing size. Now line the resistors up on the breadboard in series like so, and record the equivalent resistance of 2, 3, and 4 resistors in series. There should be an observable pattern. Write your observations down in the form of a sentence indicated in your instructions. Now write a general formula to describe the equivalent resistance of a number n resistors in series. In order to test your formula, put resistors R2 and R3 in series, and predict the equivalent resistance using your formula. For my formula, I got R equivalent series equals R1 plus R2, and so on, plus Rn. Now let's measure the equivalent resistance. It works! Let's find out why our formula works. Resistance can be expressed as R equals rho length divided by area. First, write a formula for the combined lengths of the circuit in terms of the length of each resistor. Then use the previously mentioned formula to come up with the formula we had earlier for the equivalent resistance in series. Check with your teacher. Put R2 and R3 in series again, like so. Attach the black wire to the negative side and the red wire to the positive side of the batteries. Draw your diagram nice and big. Use the loop rule, junction rule, Ohm's law, and or the equivalent resistance formula we derived in order to predict the current through R2, the current through R3, the voltage difference across R2, and the voltage difference across R3. Label these on your diagram and show your work. Then measure the actual values and compare your predicted values. Now check with your teacher again. In the next video, we'll be doing Part B of Lab D6.